Hello, it's James from XRobots.co.uk. This is part 9 of BB-8 version 3. We're quite a way along with the build now, so most of the mechanics for the ball here and the head control arm and stuff, the core pieces are built. So last time we did some stuff experimenting with the side-to-side motion with two PID controllers, one to turn that into a servo that I can move, and the other one to try and stabilise it using the inertial measurement unit. Results were mixed, but at the end of the day it looks like we've got roughly the right principle of what we need to do, and that's going to need to be adjusted anyway as I come and get the head moving and the other bits and pieces working. So today we're going to get the other main drive motor working, which should be fairly easy, so hopefully we can drive this ball around, and hopefully after that we'll get the head moving, and that's also going to take some data from the inertial measurement unit so that that can act dynamically as well. We'll come on to that shortly. So let's get right on with it. So I've had a bit of a go at that PID controller. So if you remember, I have two PID controllers. One of them controls the responsiveness of the speed that the motor moves, essentially, to meet a target position. The other one controls the position, and I control the aggressiveness of both of those. And last time I was finding it was getting stuck on one side. So essentially what it's doing is moving the side-to-side axis in the same direction as the motion to deaden the wobble. So obviously if the mass moves with it, there's nothing to wobble against. So obviously we'll just compare again with stabilization turned off, of course. So the motors are turned off, and as you'd expect, it will rock backwards and forwards. And now I'll hit that enable pin and turn the motors on, and we should find it stabilizes pretty quick. If I give that a similar push, we should find it comes back quite gracefully under control. So and you'll notice now it comes to the middle, whichever way I push it, it should settle at 0 very roughly, and I've just done that by undercompensating slightly. So instead of the trousers going and staying at the actual angle, I always try to move back to the middle. So there's a slightly more wobble on it, but it does return, and I've still got servo control. So if I now move this stick, we can see I can lean one way, and if I move it the other way, I can move the other way. So that's how I'm going to steer when I'm driving. So if I keep moving that, and then I let go of the stick, we should find it fairly quickly settles in the middle, at least much more quicker than with it unstabilised. So now the plan is to write the other PID controller to drive the main motor and keep that stable, and then we can drive the ball around. If you understood what I did last time to make it stable sideways, then this should be pretty easy to understand. I've just implemented one more PID controller called PID3. The input for that is the pitch. Before it was the roll, so the axis from the IMU in the other direction. Its set point is the input on channel 1 from the controller, which is the driving axis, and I've just scaled that there so it's not too crazy. And then it does PID compute, and the output simply is driven to the motor, to analog pins 11 and 12, which is where the motor driver is connected. And again, it stages it to another variable, and if it's less than 0, it drives it one way, and if it's more than 0, it drives it the other way, so that keeps it nice and stable. And that appears to work pretty well, so let's see how well that drives. I now have stability working in both axes. I've put this down on a thin piece of cloth. It's just a cheap throw. And that's just to stop the ridges in the ball jarring on the tiled floor, because the ball isn't perfectly smooth. You can see it's got a tendency to stop in the grooves. But if I turn on the enable pin, we should be able to see that front to back stability is now working. So as I push it, it'll try and stick there. Obviously it still balances on the ridges, but there we go. And it's stable, of course, sideways as well, so I can pretty much push this around, and I shouldn't get any wobble out of it, or at least it should deaden itself eventually. So there we go, and I can in fact drive it. So I can drive obviously front to back. That's pretty much like version 2, and it's got quite a good top speed. The stick's a bit sensitive, so I need to be careful. You can see it bouncing on the ridges in the ball there. But I can almost attempt a 3-point turn, because now I can lean the trousers. So let's try that. So I can steer pretty well, I think. I think that's working okay. I need to probably tune this up a little bit more and do something about the extreme sensitivity front to back. I'm having quite some challenges not driving too fast, but Its top speed's probably too fast to be safe at the moment. And we also need to skin that ball up because all that bouncing along is the unsmoothness of it. But the electronics appear to work pretty well. Obviously it's easier at low speed to steer, and I can steer tighter because wheels want to stand on their edge. So there's a few issues there, but on the whole, pretty happy with the way that's working. Let's just try and get off the smooth floor there. There we go. Whoa! So I still have to be careful of that. With the sides on, of course, that'll be much better. That was a pretty good test, but what's going to happen when I put the head on? So I know that it'll already balance passively, pretty much, or at least there's enough mass to keep it upright, but hopefully I can make it more stable with the active balance of the trousers. Now, if I move the head even slightly to one side, then it does cause it to lean over quite a bit. Probably even enough to steer, so I could just have the trousers keeping stability and the head steering. I do want a mode where I want to stay still on the spot, and I can move the head to one direction, and then I can compensate by moving the trousers the other way. And I had a similar mode front to back with version 2, so when I pushed the head forward, if I wanted to stay on the spot, then it actually moved the banana backwards inside, and that meant the head didn't have to move very far. It was only about 10 degrees, and it could actually move, because of the internals tilting, quite a lot further. So I think that the servos I've got moving this head around don't have enough torque for this leverage angle, and I think my head probably moves too far. So I'm going to reduce that leverage angle, and I'm going to start with conservative settings, try and tune it up and make it stable with the head on. If it works really well, I'll consider increasing them. So let's print some more servo horns and see if we can get that head active. I've made these new servo horns, which I've printed in red, and I've put the 4mm bolt in, the same as I did on the last ones, and those were attached to some really big servo horns that came with the servos, and I've screwed those on. These are 20mm in radius, so that gives me 40mm travel instead of the 80 I had before, so half the size. If these are a bit too small, we can always obviously make more, and that's the beauty of 3D printing. So I'm going to pop these in and see how far the head moves. So my head motion is pretty much back as far as that, which is just off the upright, so it doesn't lean back very far. If I wind these right forward, we can come forward a fair amount. That's about the max, but obviously the banana will move forward the other way as it drives, so that'll leave the head just on top and to the front, which is kind of as conservative as I can get, really. Side to side, we can still move off to one side quite a bit, so that's okay for me. I don't want it to go too far anyway, because it will probably tip over. I've tuned up that PID controller for side-to-side stability to take account of the head now. It hasn't been very easy, and I am a bit top heavy, so if we wobble this with everything turned off and then turn on that motor enable switch, we should see it pretty much stabilises. There's still a little bit of wobble I can't get rid of. I've basically turned up the speed at which it moves to about 5 times what it was. That's the trousers, and I can still pretty much steer side to side, so if I just want to lean over here, I can, pretty much. And it doesn't tip over. I can stay over there. So it's fairly controllable, but it is quite hard to get rid of some of that wobble. Obviously when it's moving along, it will stand on its edge anyway, so as long as it doesn't pick up too much of wobble, we should be okay. But we're not going to know what happens really till we get that head moving. And once the head can move independently, it doesn't necessarily have to stay right on top as it leans over. So that means we can use that to help compensate a little bit as well. So I need to wire in some power to the head, and then we can code it up. I need to wire the power to these servos. There's obviously one on each side. I've also got one that turns the head, but I'm going to leave that for now because it's not really required for stability. That's just for bling. And to power them, I left, if you remember, another switch to switch on and off the 12 volt feed, and that's coming from the 2 LiPos that are in parallel that powers the electronics. And I left myself a positive and negative wire there to wire power into. But of course the servos are not 12 volts, they're 6 basically, which is quite annoying because lipos aren't 6 volts, they're at least 3.7 and then 7.4 and so on. I've got 11.1s, so I need some regulation. So I'm actually using radio control car parts here. I have some Turningly battery emulation circuits, and these are apparently switching battery emulation circuits, which is good because they're efficient, and these will regulate down to 5 or 6 volts. So basically power in and power out, which would normally you'd have one of these in a radio controlled vehicle and it would power your receiver and all your servos. In this case those servos are 800 milliamps offload and I've got 2 of them, so these are 5 amp regulators and I think I need one for each servo. The servos actually, because they're so high power, come with this splitter, and it says do not plug them into your radio control receiver because it won't be able to source enough current. So they come with a cable you attach, so you plug in power separately to the servo and that would normally go to your radio control receiver, in this case the Arduino. So we need to get all of this wire attached to the wire I've already got for each servo, which is quite a bit as well, so I'm probably going to shorten these wires down and then we can hopefully power them. So each regulator is going to sit just underneath the servo neatly on the side there, and then I can just run in my data and servo PWM. Right down at the bottom of my code, underneath the main drive PID code, we've got the head servo code. So I'm taking channel 3, which is the left hand stick on the left hand bottom of the controller, and basically scaling that and constraining it. And I've got 2 variables here, one for each servo. So I've basically scaled this thing up so the head stick doesn't move all the way back. So this bit of code here is making sure I don't go negative, but when I push the stick forward it gives me all of the positive. I'm then taking channel 4 and scaling that up a bit, and then basically what I'm doing to move the head sideways is taking some of that side to side stick, taking it off the variable for one servo and adding it to the other. One servo needs to turn the other way to push to the other one because they're opposites, so then I've mapped that data for one of the servos to turn it upside down, so it scales from 0 to 180 and turns it into 180 to 0. I've then constrained those so they don't go over their limits, which will happen otherwise. And then I've also checked the enable pin to check that it's actually on, which is a 0 when it's on and a 1 when it's off. So that writes those servos to the default position if the enable pin is off on the transmitter, and when it's on it will write out the servo positions. So that means they don't try to go past their end stops when there's 0 data being received. And that seems to work pretty well with the leverage angles that I've got. So those are wired in. If I turn on this switch now, hopefully you can see this blue light come on. There's one on the other side, and these are the wires that come across here to the Arduino, and they are loose enough to allow the trousers to move, and those go into some pins down here. In fact it's 8, 9 and 10. In fact 9 and 10 are wired in now, and 8 will be for the head turning servo when I get to that, and I haven't quite wired that power supply in yet, but that's all we need to move the head around. So here we go, let's see how far that head moves. Obviously nothing happens at all when I wiggle this stick till I turn on that enable pin again. At the moment I've got the physical enable switches off on the motor drivers, so this will just activate the head. So if I push this stick forward, my head goes forwards and backwards a bit. It doesn't go all the way back as a result of those leverage angles, and I can move sideways, but of course because I can't move back I can't move directly sideways at the moment, so I kind of get a forwards motion, which isn't too bad, and of course I can roll around like so. Probably need to sort out the scaling, but that's enough for now, as long as I can lean forward to compensate for the banana picking up when it drives. So here we are again. So I found that the floor isn't at all flat in here, so I've positioned it this way round because that's the flattest place I can find. I've actually tuned up the PID controllers again so it's a lot more stable with the head on, but of course the head moves as well, and I'll hope to demonstrate what we can do with the head and the body automatically eventually, but for now manually. So if I'm just going to give it a shove again, then I'll turn on stabilization. So this is everything off, and obviously it wobbles a lot, and as soon as I turn on stabilization, hopefully it should bring itself stationary. Now there is a bit of wobble, but it's much better with the stabilization on, and of course I can still move this manually, and if I'm very careful not to tip over, which is possible, I can pretty much hold a position and return to the middle fairly under control the other way, and I should be able to get it to stay fairly stable. Does a couple of wobbles, but that's to be expected. So what I want to be able to do is, as I move the head one way, is move the trousers the other way, which I'll try and do manually for now, but eventually it'll all be controlled by the IMU to try and stay everything stable. So if I move the head this way and the trousers that way, the aim is we should be able to stay on the spot. So we can move the head around, and the same will happen front to back. So as I move the head forwards, if that motor was on, I'd have it move the other way so that it stays still on the spot. So that's going to be a thing, but for now we need to try driving it as it is with the manual control and just driving around and leaning as we go and seeing how well that works. I was going to give that a drive, but I found that there's actually quite a fundamental mechanical issue. So everything's good if I drive slow, but if I stop or drive too fast, obviously I need to put the head forward because the banana moves forward, the head goes back, so I need to push the head forward to drive forward so that as I tilt the internals, this goes forward and it's quite nicely positioned just forward as it drives along. But the problem is if I stop suddenly or lean forward too much, hear a little sound there. Basically what's happened is the magnetic head coupling is so strong it's pulled the whole thing up and it's pulled the drive wheel off. So now if I turn this on and try and drive forwards, we don't get anything at all. And if I just zoom in on there, hopefully you can see that my drive wheel is going round, trying to drive forward to stabilise, but it's not actually touching the ball. So that's not very good on the whole. And if I pull the head off, now it works. Great. It does pull quite a lot of torque there as well. So that'll be awesome. So basically, I know what's happening and we're going to need to do a fix. So what is in fact happening is there's too much magnetic attraction in the head there, but I really need it to keep the head on. But in fact this wheel is getting lifted off because it's pivoting over on the front little guide wheels, and there's one of those each side, and the whole thing is basically tilting over, and that's causing this to lever the main drive wheel off. And these I think are really required, even though I'd like to take them out for reasons I'll explain shortly, just to basically hold this banana true in here and stop it scraping on the bottom of the ball. If you remember from the early episodes, I've actually mounted the ballast, including this flywheel and the whole trouser section, higher than I wanted to, because you can see there's actually a gap just in there where you can see daylight through. So this whole mechanism was supposed to be about 15 mil lower, and the reason I didn't mount it lower was because as basically this whole mechanism moves sideways, the trousers and the flywheel, they actually run into those same guide wheels. So as this tilts, it hits those, and I ended up mounting them higher so it could move further. So I do have an option to put this whole lot lower and bring the mass lower, which might stop that action, because this is 6 kilograms of lead, so it would actually bring it lower, and it would probably bring more mass over that drive wheel. So I'd have to make those guide wheels smaller. There's 2 that side and 1 at the back. So that is an option by knocking 10 mil off the diameter, which would bring them down by 10 mil. So that's one thing I could do, but I still think that this won't move as far because then it hits other things like the main drive wheel sooner. So I think what I'm going to do in fact is put some guide wheels at the front. So right in there on this end of the banana, I'm going to get some more of those wheels and have them run against the ball, pushing this way to stop it slipping forward. And in fact when it does slip forward, I can just put my hand in and pull it back, and there's not too much force. So I think I just need something mounted on the top of the banana right behind the electronics, just a couple of extra guide wheels. I've removed the electronics there, which just undo, which was just for this sort of thing. So I need to put some wheels on top of that. Now there's a section that comes out, which I'm probably going to replace, and it's held on with 2 bolts. And I'm going to use some more of these guide wheels, which have got the bearing mounted in the middle. Look back on the previous episode to have a look how they were made. 2 of those facing the ball this way, but I want to make them adjustable so that I can adjust how much tension they apply, and I want to sit them, I guess, fairly wide, but we'll see what I can come up with that fits in there and allows me to block it out. And that piece is going to look like this. So if I just get rid of the ball here, we can see we've got this piece here, and it's on this cunning pivot. So basically this will be able to, roughly that's aligned with the ball, but it'll be to pivot forwards, and the lever sticking out the back here, there'll be some sort of saddle that sits on top of the drive axle that I can pad out to push those wheels for just the right amount, and that's probably going to be a NinjaFlex tower, so it's slightly suspension-like. And I have a little recess there to sit it in so I can block something in. So I can adjust the tension just by putting shims in or whatever I want, or make it as rigid or as soft as I want. So I'm going to have some trouble assembling it. I think this piece is going to have to be fitted first on the existing bolt holes. Then I'll have to put this piece on and then put the wheels on afterwards, or I won't be able to get to the screw tops that are here. But we'll get those parts printed and see how it looks. Here it is. So this piece hinges like this. And I'll have to put this together in stages. So first of all, we'll bolt that onto the existing bolts. So that'll be accessible. Then this piece will go on and the piece of studding will slide through. And lastly, I'll put the wheels on and get those right at the right gauge to run on the smooth parts that I sanded before. And once that's all together, we should find that in about this position, this just touches the edge of the ball, and then I can fine tune it as I wish to by putting blocks under this piece, pressing against the axle. I've fitted it, you can just see it in there, and if I lift this, if I can get my hand out of the way, you'll see that that will brace the wheels against the edge, hopefully. So I need to put a block underneath, bracing it against the drive axle to really push that back. Trying to drive this manually and move the head forward at the same time turned out to be really hard, so I've saved myself a bit of trouble, written a little bit of code that takes some of the IMU in this direction and adds it onto the head stick. So if I turn this on now and drive it forward, you should hopefully see these servos turning, and you should see the head actually moves forward to stay on top, which means I can drive relatively well. Now there are some issues, but let's see how well that works. So driving forwards straight is pretty good. There goes that head stick, and it should level out when I get to the end. I can just about steer by leaning the trousers, but I have to be incredibly careful not to tip it over. So let's just get going and then lean over this way. There we go. And it recovers fairly well. And I can make quite a tight turn if I drive really slow, although it is quite hard and I do risk tipping over, so I'm still feeling a bit top heavy. That's about the tightest turn I can make, which is a pretty tight turning circle, but I have to go really slow. The two main issues I've got are that it is still quite easy to fall over, and if I move that head over and I move the trousers, in fact, I can overbalance, which, as I say, won't be so much of an issue with the head on. But the other issue is the head doesn't always return to the middle, and I can't drive backwards very easily. And those are both associated with the flexibility in the head here, which is quite wobbly actually, which is also why it wobbles like this as it drives along. And that's owing to the NinjaFlex linkages in these levers. So I think I need to firm those up a bit. If I drive backwards, in fact, the triangular piece all turns inside out because the NinjaFlex pieces kink up, so in fact the head can be forced all the way back further than it's supposed to, and all of the servos get upset. So I need to firm up those linkages, then we can try driving again. Hopefully it will go where I want, and also I'll be able to drive backwards. Here are my existing linkages, and if I wobble that you can see there's quite a lot of slack in it. So I'm going to replace those with some printed in semi-flex, so let's compare those two. They look fairly similar. You can see I've made these slightly thicker and these are slightly thicker as well, but this is actually printed in NinjaFlex Semi-Flex, which is a lot less flexible. There's still some flex, but compared to the original parts, a lot less in fact, and these, what was happening was these are sort of kinking up like this, but I don't think I can do that to this one. Sort of just, but not really. So these are going to be a lot stiffer. I've made them slightly wider, and I have with these as well. So instead of these just buckling around, they still flex, but with this being screwed down as well with the bracket, that should be much better. So I'm going to change those over, and we'll see if that's a better drive and if I can go backwards. Those are swapped in, and now that is a lot more rigid. So hopefully that's going to hold the head in the middle better and also stop it all buckling when I drive backwards. If I drive directly forwards and backwards, hopefully we can see the head stays perfectly in the middle now and the thing stays fairly true. Probably need to control deceleration with the stick rather than letting go of it, but there we go, and backwards works as well. Alright, so that's good, and I should be able to just steer over here. There we go. Yep, definitely need to be careful when I let go because there's a bit of overshoot, which is owing to it being quite top heavy. But on the whole, that is working much better now. Let's just see if I can steer back towards the camera. Whoops. And let's just reverse up this way. Yeah, okay, so that's not too bad, and it does stay upright, and you can see that any wobble there, apart from front to back on the ridges in the ball, seems to deaden out pretty quick as well. Let's just try and decelerate under control. It's quite a bit of head wobble still, and I'm not sure how much of that is the ridges in the ball and how much is the magnetic head coupling wobbling now. But I'm on the whole fairly okay with it. The head does dip a bit when it slows down because it can't pull the stick back enough to pull it up. But if I slow down slow enough, and I could build in a deceleration algorithm, then that's pretty good. Or I should probably just learn to drive and be able to stop suddenly if I want to in case there's an emergency. But on the whole, I think that's not too bad. I feel like that pretty much works, so I'm going to leave this video here, and I've got quite a bit of thinking to do about what to do next. So although it works okay, it still seems a bit top heavy. So the option of course is to move down this whole flywheel by 15mm, put smaller guide wheels in the bottom, and hopefully that'll fix it. The problem is if that doesn't fix it, then I need to put some more ballast in the bottom, and at the moment there's space for probably maybe 3 or 4 kilograms more lead in little pockets spread around. But if I move down the whole mechanism and move the flywheel down, there won't be space anymore, so I'm not sure which of those to do, whether I move it down or whether I don't move it down and just put some more ballast in. It would appear the trousers can move side to side fast enough and far enough to stabilise it and over-stabilise it, in fact to tip it. So maybe it is that I just need some more stationary mass, but I'm not really going to know till I get this flywheel spinning round to see how much force that can exert to actually spin the droid round. So I think the next step is probably getting the flywheel working, getting the head turning, which is pretty simple, try driving it, see how well it can spin on the spot, then we'll decide what to do about either moving it down or putting some more ballast in. So I need to do some thinking there, and I need to order some parts. So that's going to be the end of this episode, but don't forget to subscribe to check out more updates on this project and other projects, and also check out BB-8 version 2 if you want to see what I did before this, and version 1. Also, there are social media links in the description to this video, including my new Instagram accounts.